Hello guys, welcome back to my channel Code by Vansh, and today we are going to solve the question, is graph bipartite? So let's begin. So in this question what we have given there is an undirected graph with n nodes where each node is numbered between 0 and n minus 1. You are given a 2D array graph where graph U is an array of node that node U is adjacent to more formally for each V in graph U. Okay, so we have given basically the adjacency list here, and we can see that the graph is followed here. So there are different steps, like there are no self edges, there are no parallel edges. If V is in graph U, then U is in graph V. Okay, our graph is bipartite if the node partition independent set A and B such that connects node A and B and B. Return true if it is only bipartite. Okay, so how can we solve this question? So first of all, we have to know what is the meaning of bipartite. So if we make a graph like 0, then 1, then 3, and then 2. Okay, so if I make this graph as if I am iterating through this 0, if I color it 0, okay, so after I go 0 to 1, it will become 1. Then I will go here and I will see that it is 0, and then the next one is 1. So as I can see that 0 is connected through 1, 2 and 3, and as 0 has a color of 0, it don't have to follow the coloring of 1, 2 and 3. Like if 0 has a color of 0, then the 1 has to follow the color 1, 2 also has to follow the color 1, and 1 also has to follow the color 1. But if I look at 2, its color is 1, right? But 1 and 3 also has a color of 1, so no two adjacent color has to be same. Adjacent color have to be different, like as you can see in this example 0, 1, 2 and 3. Here if I mark my 0 as 0 color, 1 as 1 color, then 0 and then 1, then all these adjacent are always different. Like if I look at 3, the 3 color has 1 as color, it is different from 0 and it is color from 0 also. If I look at 0, then it is also different from 0, 1 and 0, 1. As you can see here also it is 1. So that's why this is a bipartite graph. True. I will give this as true, and here I will return it as false. So this is the basic understanding of the question. Now let's move to the intuition part, or how we are going to solve this. So in order to solve this question, what I am going to do, first I am going for a BFS, because as you can see that BFS is a level wise order traversal, and here also you can see that the way I am traversing is a level wise. Like first I am going 0 to 1, then 1 to 2, then 2 to 3. Okay, so this is a level based traversal. So how I am going to do this? So first I will take an array. This is the array which contains basically all the nodes color. So our nodes are 0, 1, 2 and 3, right? So first I will initialize all the colors as -1, -1 and -1, right? Then what I will do, I will just create a queue, because queue follows the BFS traversal. So I will put 0 in the queue as it is the starting, and as I put 0 in the queue, I will pop out, and when I pop out, I will change the color 0 to 0. This is the thing I am going to follow. Then what I am going to do, I am going to put 0's neighbor, and here in this case 0 has 3 neighbors, 1, 2 and 3. So what I am going to do, I am going to put 0, 1 and 3 into our queue. So now 1 is going to come, and when I'm going to check 1, it the 0 is our node. At this position 0 is our node, so I'm going to check 1, and as I can see that 1 is also -1, so this means I don't traverse -1. So what I am going to do, I am going to change its color to, as the 0 color node has 0 color, so I will make it adjacent and I will change the color to -1, right? Then I will pop it, and now our node is 1. So it's just I am just traversing through our graph, which is adjacency list, and this is the process I'm going to follow, right? I'm going to just take the value and then I'm going to just traverse it. So after this 2 is going to pop out and 3 is going to pop out. Now when 3 is going to pop out, now this color is also going to become what is going to become 0 1, and then it is also going to become 0. But now as I can see that when I pop 2, it will bring 2 is connected to 1 3 and 0, and I can see that 0 and 0 is also occurred, so they both have equal color. So that's why I will give a false for the answer. So this is the process I'm going to follow. Now let's move to the coding part. Here in the coding part, as you can see, what I'm going to do, I'm first going to this is the queue I have made. After the queue made, this is actually the VFS part. Here you can see if the queue is not empty, then what I'm going to do, I'm going to just take the front part, and after the front part, what I'm going to do, I'm going to iterate through the graph, and if the color is -1, this means it is not traversed yet. So what I'm going to check, if the node value is equal to the is not equal to the IT, and if it is not equal, then we are good to go. Then we are just going to push it into the queue. But if they both are equal, then this is a red flag, and I am going to return false, because a bipartite graph is a graph in which both the adjacent nodes has different color. Like if this is a 0, then the other color would have been 1. So this is the thing. After this, all the processing I will return true, because if the code break, it will tell us that this is not the answer. So in the driver part also, you can see that I have just take the n, and I have colored all as -1, and then after this, what I'm giving, if this part is coming or not. If it is a if this is a code part, then it will give us false, as it will give us true as the answer. So this is the explanation part. I hope you like my video. Make sure to like, share and subscribe for more upcoming videos. Thank you.